In the world of material science, the potential for transforming ordinary substances into extraordinary forms is a concept that has fascinated scientists for decades. The idea that peanut butter, a common, everyday food, could be transformed into diamonds may sound absurd at first, but it's rooted in the very principles that govern the chemistry of carbon and the conditions under which diamonds form. To understand how this seemingly impossible transformation happens, we must first dive into the nature of diamonds themselves and explore the unique properties of carbon. Diamonds are one of the most coveted substances on Earth, not just for their beauty and rarity, but for their exceptional hardness and unique crystal structure. At the atomic level, diamonds are made entirely of carbon atoms. What makes diamonds so special is the way in which the carbon atoms are arranged. Each carbon atom in a diamond is bonded to 4 other carbon atoms in a strong tetrahedral arrangement, creating an incredibly hard, three-dimensional network. This structure is what gives diamonds their unparalleled strength, and it's the same structure that scientists can recreate in the laboratory under the right conditions. The idea of transforming peanut butter into diamonds revolves around the concept that the carbon in peanut butter can be restructured into this crystalline arrangement. Peanut butter, while not a carbon-rich material in the same way graphite is, does contain carbon in the form of organic molecules such as fats and proteins. By applying extreme conditions of pressure and temperature, scientists can force the carbon atoms in peanut butter to rearrange themselves into a more stable, crystalline form, ultimately resulting in the formation of diamonds. The process of turning peanut butter into diamonds starts in a laboratory setting, where the peanut butter is placed inside a high-pressure chamber. In this chamber, conditions are manipulated to replicate the natural processes that occur deep within the Earth's crust. There, under the immense pressure and heat, carbon atoms can undergo a process called carbonization, where the carbon begins to crystallize. For natural diamonds, this process takes millions of years, but in a laboratory, scientists can accelerate the process by applying controlled heat and pressure. This allows them to create synthetic diamonds in a fraction of the time it would take for natural diamonds to form. One of the most interesting aspects of this process is the fact that the peanut butter itself undergoes a dramatic transformation. The fats, proteins, and other organic compounds break down under the high heat, leaving behind carbon atoms that are then restructured. Unlike the graphite-based diamonds typically created in laboratories, the carbon derived from peanut butter is not a pure substance to begin with. It's a mixture of different compounds that must be manipulated and broken down before it can take on the form of a diamond. This makes the process not only a technical challenge but also an artistic one, as scientists must carefully balance the conditions to ensure the carbon atoms rearrange in the right way. This transformation challenges the traditional notion of what a diamond is. Historically, diamonds have been considered rare and precious because they form deep within the Earth over millions of years, subjected to high pressure and temperature over long periods of time. The idea of synthesizing diamonds quickly and from something as mundane as peanut butter upends this perception, showing that the process of diamond formation is not reserved for the Earth's mantle alone. Instead, with the right scientific knowledge and technology, diamonds can be created from virtually any source of carbon, no matter how ordinary. The implications of this discovery are far-reaching. While the process of converting peanut butter into diamonds may be more of a scientific novelty than a practical solution, it opens the door to new possibilities in material science. Synthetic diamonds are already used in a range of applications, from cutting tools to electronics, and the ability to create diamonds from unconventional sources could make them more affordable and accessible. It could also lead to more sustainable practices in diamond production, reducing the environmental impact associated with traditional diamond mining. Beyond industrial uses, the conversion of peanut butter into diamonds serves as a profound example of how science and technology can transform even the most ordinary materials into something extraordinary. It's a reminder that what we perceive as commonplace may, in fact, contain hidden potential that can only be unlocked through the application of scientific principles. As we continue to explore new ways of manipulating matter at the molecular level, we may one day find that even more substances, from food to waste materials, can be transformed into something entirely new and valuable. The conversion of peanut butter into diamonds also raises interesting questions about the future of synthetic materials and the ways in which science can alter the course of natural processes. While the transformation from peanut butter to diamonds may seem like a quirky experiment, it also speaks to the broader field of synthetic diamond production. In recent years, the demand for diamonds has extended beyond luxury jewelry, and synthetic diamonds have found significant use in industries such as manufacturing, electronics, and even medicine. Synthetic diamonds, created through processes such as high-pressure, high-temperature or chemical vapor deposition, have been in use for some time. These diamonds are chemically identical to natural diamonds, but they are created in a much shorter time frame. In fact, diamonds created from peanut butter are just another iteration of this technology. But they come with a unique twist: they are made from organic materials rather than pure carbon sources like graphite. By using something as readily available as peanut butter, researchers are demonstrating that the possibilities for synthetic diamonds are nearly limitless, and that the material could be produced more sustainably than ever before. As the demand for synthetic diamonds grows, the environmental impact of diamond mining becomes a key consideration. Traditional diamond mining has long been associated with significant environmental degradation, as well as ethical concerns related to labor practices. By creating diamonds from organic substances like peanut butter, we could significantly reduce the environmental footprint of diamond production. Instead of extracting diamonds from the earth, which involves energy-intensive processes and causes ecological damage, we could produce synthetic diamonds with far less impact on the planet. This makes the concept of creating diamonds from peanut butter not only scientifically intriguing but also ecologically promising. The process also challenges the very idea of rarity that has long been associated with diamonds. In many ways, diamonds have become symbols of wealth and status, their scarcity driving their high value. But with the ability to synthesize diamonds from materials as common as peanut butter, we may soon find that diamonds no longer hold the same exclusivity. Instead of being symbols of wealth, diamonds could become more readily available for use in various industries, from electronics to medical technology. This democratization of diamonds could have profound implications for both the jewelry industry and the scientific world. As more experiments are conducted to refine and expand this process, it's possible that the future of diamonds may look very different from the one we know today. We might soon see diamonds produced from all kinds of organic materials, from food waste to plant matter, further challenging our perceptions of what diamonds are and where they come from. This could pave the way for entirely new applications of diamonds, ranging from sustainable manufacturing practices to innovative medical devices. The story of peanut butter being turned into diamonds isn't just about the potential for creating valuable materials from everyday substances. It's also about the broader impact of material science on society as a whole. The ability to synthesize diamonds from organic materials has the potential to revolutionize not only the way we view diamonds but also how we approach sustainability in manufacturing and resource management. In recent years, there has been a growing shift toward using more sustainable materials in industrial applications. As industries continue to look for alternatives to natural resources, synthetic diamonds offer an intriguing solution. Their hardness, durability, and versatility make them invaluable in everything from cutting tools to semiconductor technology. And as scientists develop new ways of creating synthetic diamonds, we could see a future where these diamonds are produced from renewable and eco-friendly sources, such as plant-based materials or food byproducts. The research into turning peanut butter into diamonds also highlights the innovative spirit of modern science. It underscores the importance of creativity in scientific inquiry and the willingness to explore unconventional ideas. What might seem like a simple experiment or a scientific curiosity today could lead to groundbreaking discoveries in the future. In fact, the process of converting peanut butter into diamonds could inspire further exploration into the use of other organic materials for synthetic diamond production, opening up a world of possibilities for creating diamonds in more sustainable and efficient ways. As this field of research progresses, we may find ourselves in a future where diamonds are no longer symbols of rarity and luxury, but instead, they are commonplace materials that can be produced from a variety of organic substances. This shift could democratize access to diamonds and reduce the negative environmental impacts associated with traditional diamond mining. Ultimately, the transformation of peanut butter into diamonds could be just the beginning of a larger movement toward a more sustainable and innovative approach to material science. The potential for converting peanut butter into diamonds is a striking example of how science can turn the ordinary into the extraordinary. It serves as a reminder that even the most unassuming substances can hold incredible potential when manipulated by scientific knowledge. Through high-pressure, high-temperature techniques, scientists are able to unlock new forms of matter, creating synthetic diamonds in ways that were once thought to be impossible. As research in this area continues, we may see more unexpected substances transformed into diamonds, offering new possibilities for industries and applications that rely on the unique properties of this remarkable material. In this way, the transformation of peanut butter into diamonds is not just a scientific curiosity, it's a window into the future of material science and the endless potential for innovation. As we continue exploring the fascinating journey from peanut butter to diamonds, it's important to dive deeper into the mechanics of synthetic diamond creation, specifically examining the various techniques that have made this possible and their potential future applications. While the concept of transforming peanut butter into diamonds may seem like a novelty, it aligns with a larger field of research that seeks to harness the properties of carbon for industrial and scientific purposes. One of the primary techniques used for synthetic diamond production is high-pressure, high-temperature. This method simulates the extreme conditions found deep within the Earth's mantle, where natural diamonds form over millions of years. The process begins by taking carbon-based materials, such as graphite, methane, or in this case, peanut butter, and subjecting them to extreme heat and pressure. Under these conditions, the carbon atoms rearrange themselves into a perfect crystalline structure, forming a diamond. In traditional high-pressure, high-temperature, pure carbon sources are used to create synthetic diamonds, but the transformation of a more complex organic material like peanut butter adds a level of intrigue to the process. Since peanut butter contains a combination of fats, proteins, and sugars, the molecules must first be broken down into simpler forms before the carbon can undergo crystallization. This means that peanut butter requires an additional step compared to pure carbon sources, where the organic compounds must be converted into a carbon-rich form that can form diamonds under pressure. The process of creating diamonds from peanut butter also highlights the growing field of material science, which aims to discover new and efficient ways to manufacture diamonds for various uses. While diamond mining remains a key industry, the environmental and ethical concerns surrounding traditional mining methods have prompted the exploration of more sustainable alternatives. Synthetic diamonds, especially those produced using renewable or repurposed materials, offer a potential solution to these challenges. The ability to produce diamonds from materials like peanut butter or other organic waste could significantly reduce the environmental impact of diamond production, making it a more sustainable and ethical practice. Synthetic diamonds are already being used in a range of industries, from electronics to manufacturing, due to their unique properties. Their exceptional hardness makes them ideal for cutting, grinding, and drilling, while their conductivity and optical properties are valuable in electronics, lasers, and other high-tech applications. The creation of diamonds from organic materials could further expand their applications, offering a new avenue for sustainable production and use in industries where they are not currently employed. For example, the use of peanut butter-derived diamonds in cutting tools could reduce the need for mining natural diamonds, which often leads to environmental degradation and habitat destruction, in addition to their industrial uses. Synthetic diamonds hold promise in medicine. For instance, diamonds are already being investigated for use in medical devices such as prosthetics, dental implants, and cancer treatments. Their biocompatibility, durability, and unique chemical properties make them an ideal material for medical technologies that require precision and resilience. The ability to produce diamonds from organic materials like peanut butter could make them more cost-effective and accessible, opening up new possibilities in medical applications where diamonds could offer enhanced performance and longevity. Furthermore, the process of creating diamonds from peanut butter demonstrates the potential for other organic materials to be converted into valuable resources. The growing interest in sustainability and resource recycling has led to research into using food waste, plant matter, and other byproducts to create high-value materials. By leveraging the carbon in these organic materials, we can create everything from diamonds to carbon nanotubes, which have applications in a wide range of industries, including electronics, energy storage, and even environmental cleanup. The ability to turn waste into something valuable not only has economic implications but also helps address global challenges related to resource depletion and waste management, as researchers continue to refine the process of creating diamonds from peanut butter and other organic materials. We may see a shift in the way we think about material production. Instead of relying solely on natural resources, scientists could turn to abundant and renewable sources to create diamonds and other high-value materials. This approach could reduce the strain on the Earth's ecosystems, while also helping to meet the growing demand for materials that are both sustainable and technologically advanced. The success of creating diamonds from peanut butter also offers a glimpse into the future of synthetic materials, where the boundaries between natural and artificial are increasingly blurred. As technology advances, we may witness the development of entirely new forms of diamonds and other materials, each with their own unique properties and applications. This evolving field of material science could lead to breakthroughs that revolutionize industries ranging from energy storage to medicine, creating new opportunities for innovation and sustainability. In addition to its practical applications, the discovery of how peanut butter can be transformed into diamonds challenges our fundamental understanding of what materials can be manipulated and how. It raises questions about the nature of diamonds themselves. Are they truly rare and precious, or are they simply a product of the right conditions? And if diamonds can be created from something as ordinary as peanut butter, what other common substances hold the potential for extraordinary transformations? The implications of this discovery extend beyond the world of diamonds. The ability to transform ordinary materials into high-value products is a testament to the power of scientific innovation and creativity. By understanding the underlying principles of material science, researchers are unlocking new possibilities for how we can use carbon and other elements to create new technologies and solutions to some of the world's most pressing problems. In this way, the process of creating diamonds from peanut butter is just one example of the endless potential that exists when we look at the world around us with a scientific lens. While much of the focus on creating diamonds from peanut butter has centered around the scientific process itself, the broader implications of this research are equally compelling. As synthetic diamonds continue to become more mainstream, the social, economic, and environmental impact of this innovation cannot be overlooked. The ability to produce diamonds from organic materials could challenge long-held beliefs about the rarity and value of diamonds, making them more accessible and affordable for a wide range of applications. Historically, diamonds have been viewed as symbols of wealth, luxury, and status. Their rarity, coupled with their undeniable beauty, has made them highly sought after for centuries. But the rise of synthetic diamonds, and the possibility of creating diamonds from everyday materials like peanut butter, raises questions about the value we place on these precious stones. If diamonds can be produced in a lab using a variety of organic materials, how will this affect their desirability in the marketplace? Will diamonds still carry the same cachet, or will they become more commoditized as a result of their synthetic origins? The potential democratization of diamonds could also lead to a shift in how we view material wealth. If diamonds are no longer rare and difficult to obtain, they may lose some of the mystique that has long surrounded them. This could have profound effects on industries that rely on diamonds for their symbolic value, such as the luxury jewelry market. As synthetic diamonds become more common, we may see a shift in consumer preferences, with buyers placing greater emphasis on ethical sourcing and sustainability rather than rarity alone. In conclusion, the creation of diamonds from peanut butter is more than just an interesting scientific experiment, it's a window into the future of materials science and synthetic diamond production. By harnessing the power of high pressure and temperature, scientists are pushing the boundaries of what's possible, creating diamonds from the most unexpected sources. Whether for industrial use, medical applications, or sustainable manufacturing, this breakthrough holds the potential to transform industries and challenge our perceptions of what diamonds are and how they can be created. As we continue to innovate and explore the possibilities of material science, the future may hold even more surprising transformations that push the limits of what we once thought was possible. As the journey from peanut butter to diamonds continues to unfold, it becomes clear that this discovery is not just a breakthrough in the realm of synthetic diamond production, it also marks a significant step forward in how we approach material science, sustainability, and resource utilization in an increasingly resource-conscious world. The process of transforming peanut butter into diamonds, while still a laboratory curiosity, opens up new possibilities for material creation and challenges the very notion of waste and value. At the core of this transformation lies one of the most fundamental principles in material science, the idea that the properties of a material can be altered dramatically through the application of extreme conditions. Whether it's heat, pressure, or other forms of manipulation, the molecular structure of a substance can be fundamentally changed to create something entirely new. For peanut butter, a substance that is mostly fats and proteins, applying the right pressure and heat causes the carbon atoms to rearrange into a crystalline structure, resulting in the formation of diamonds. But this experiment offers more than just a way to create diamonds. It serves as a key example of how materials science can help address some of the most pressing challenges facing humanity, particularly in the areas of sustainability and waste management. If peanut butter, something so commonplace, can be transformed into a high-value material like diamonds, what other materials could we be overlooking in our quest for sustainable resources? The potential to use waste materials, such as food byproducts, agricultural residues, or even industrial waste, to produce valuable materials is an exciting area of research. Rather than treating these materials as burdens to be discarded, we could instead find ways to repurpose them into usable, high-demand products. The implications of this approach could be transformative for industries that rely heavily on natural resources. Mining, for instance, is an energy-intensive process that has significant environmental consequences. From deforestation to water pollution, the environmental impact of mining for diamonds and other valuable minerals has led many to seek alternative, less damaging ways of obtaining these materials. By developing technologies that allow us to create diamonds from organic waste, we could greatly reduce the need for traditional mining, significantly cutting down on ecological damage. This shift would not only help preserve natural ecosystems but also reduce the carbon footprint associated with resource extraction. Moreover, the ability to create diamonds from organic materials could lead to the development of a circular economy, where waste is continuously repurposed into valuable products. This concept is already being explored in a variety of industries, where the goal is to reduce waste and make better use of existing resources. The peanut butter to diamond process could become a blueprint for other materials to be repurposed, turning what was once considered waste into a valuable commodity. The wider adoption of such processes could shift industries toward more sustainable practices, where the focus is not just on extraction but on creating value from the materials that already exist around us. The future of synthetic diamonds also hinges on the ability to create these materials in a way that is both economically viable and environmentally responsible. As synthetic diamonds continue to gain traction in various industries, their cost-effectiveness and sustainability will become increasingly important factors in their widespread adoption. At present, the production of diamonds, even in synthetic forms, is still an energy-intensive process. The energy required to maintain the high pressures and temperatures necessary to form diamonds is significant, but the potential to scale this process with renewable energy sources could help mitigate these concerns. By using solar, wind, or even geothermal energy to power these diamond-producing processes, we could significantly reduce the environmental impact of diamond production, making it a much more sustainable option in the long term. The advent of synthetic diamonds produced from organic materials could also drive innovation in sectors that require diamonds for their unique properties, such as electronics and nanotechnology. Diamonds, with their remarkable hardness and conductivity, are already being explored for use in advanced semiconductor technology, which is crucial for the development of faster and more efficient electronics. In the future, diamonds made from waste materials or organic substances like peanut butter could become an important component of this technology. Providing a more cost-effective and sustainable alternative to traditional diamond sourcing. In addition, the versatility of synthetic diamonds made from peanut butter or other organic materials could lead to new and innovative applications in fields like medicine. Diamonds are already used in a range of medical devices, from prosthetics to cutting tools for surgeries, due to their biocompatibility and extreme durability. The potential to produce these diamonds more affordably and sustainably could pave the way for greater access to life-saving technologies. For example, the creation of medical-grade diamonds at a lower cost could lead to more widespread use of these materials in dental implants. drug delivery systems, and even in high-precision instruments for surgery. One of the most intriguing aspects of this process is its potential to democratize the diamond industry. For centuries, diamonds have been seen as a symbol of wealth and status, often associated with rarity and exclusivity. However, as synthetic diamonds become more prevalent and the technology to produce them advances, diamonds could become more accessible to a broader population. The ability to create diamonds from peanut butter or other organic materials could shift the narrative around diamonds from being a luxury good to a more widely available and versatile material. The democratization of diamonds could have ripple effects across various sectors, from the jewelry industry to industrial manufacturing. As the demand for diamonds grows, particularly in fields like electronics and medical devices, the availability of synthetic diamonds made from sustainable and renewable sources could help ensure that supply meets demand. By making diamonds more accessible, we could see a shift in how diamonds are perceived, moving away from their status as an exclusive commodity to being viewed as a practical and necessary material for a range of industries. In conclusion, the transformation of peanut butter into diamonds is not simply a curiosity but a powerful symbol of how material science can reshape our understanding of the world around us. Through the application of extreme pressure and temperature, a common food can be converted into a rare and valuable substance, demonstrating the potential of science to unlock new possibilities for material production. This process also raises important questions about sustainability and resource management, offering a glimpse into a future where waste materials could be repurposed into valuable products. As research into synthetic diamond production continues to advance, it's clear that the future of diamonds, whether from peanut butter or other organic materials, holds significant promise. The ability to produce diamonds sustainably, affordably, and at scale could revolutionize industries ranging from electronics to medicine, providing solutions to some of the world's most pressing challenges. This breakthrough is more than just a scientific achievement, it represents a new way of thinking about the materials we use and how we can create value from the resources that are already available to us. With innovation driving progress, the transformation of peanut butter into diamonds is just the beginning of what could become a new era of material science. As we explore the continued evolution of synthetic diamond production, especially through unconventional means like the transformation of peanut butter, it becomes increasingly evident that the future of material science is poised to radically reshape multiple industries. Beyond simply creating diamonds, this process serves as a cornerstone for broader advancements in chemistry, resource management, and sustainable innovation. The implications of transforming a common organic material into one of Earth's most coveted substances could extend far beyond the world of diamonds, triggering a paradigm shift in how we view resource utilization and production across various sectors. One of the most compelling aspects of the peanut butter to diamond process is its potential to contribute to the circular economy, a model that seeks to reduce waste and make better use of resources. In traditional linear economies, resources are extracted, used, and discarded, often leading to environmental degradation and resource depletion. However, the circular economy emphasizes the reuse, recycling, and repurposing of materials. By transforming waste, whether it's food byproducts like peanut butter or other organic matter, into valuable materials like diamonds, we begin to close the loop on resource consumption. This approach not only helps reduce waste but also maximizes the utility of existing resources, minimizing the need for new extraction and production. The concept of creating diamonds from organic materials, including food waste, also invites us to reconsider what is valuable. Diamonds have long been symbols of wealth, rarity, and exclusivity. They have been prized for their beauty, hardness, and industrial applications. However, when you shift the production of diamonds from the realm of rare, earth-mined resources to more common, renewable sources, you fundamentally challenge the value that society places on these materials. What once required millions of years to form in the Earth's mantle can now be produced in a lab, from something as humble as peanut butter. As a result, diamonds may no longer be regarded as exclusive luxury items. Instead, they could become more accessible and valued for their utility rather than their rarity. This shift in how we perceive diamonds also has the potential to democratize access to the material, especially for industries that rely on diamonds for their unique properties. As we have seen, diamonds are not just coveted for jewelry, but they are essential for high-tech applications such as cutting tools, electronics, and medical devices. By reducing the cost of synthetic diamonds, we could make these applications more affordable and accessible to a wider range of industries, from manufacturing to healthcare. For example, the use of diamonds in electronics could lead to the creation of more efficient and durable devices. With diamonds used as semiconductors, in optical components, or as heat sinks in cutting-edge technology, furthermore, synthetic diamonds produced from organic sources could revolutionize the medical field. In addition to their traditional uses in dentistry and prosthetics, diamonds have shown promise in areas such as cancer treatment and drug delivery systems. Their unique properties, biocompatibility, extreme hardness, and optical clarity, make them ideal for use in medical devices that require precision and durability. The ability to produce diamonds more affordably and sustainably could pave the way for their increased use in life-saving treatments and medical technologies. For instance, the creation of medical-grade diamonds from organic materials like peanut butter could allow for more cost-effective implants, surgical tools, and drug delivery systems, benefiting patients and healthcare systems alike. Another exciting aspect of synthetic diamonds made from organic materials is their potential for use in nanotechnology. Nanomaterials, which are materials structured at the nanoscale, typically 1 to 100 nanometers, have a wide range of applications in fields such as medicine, energy, and electronics. Diamond nanoparticles, due to their exceptional properties, are already being explored in various nano-based technologies. By producing diamonds from more sustainable sources, researchers could open new doors for the development of advanced nanomaterials with a variety of uses, from targeted drug delivery to high-performance batteries. These advances could have far-reaching effects, improving everything from energy storage systems to environmental cleanup processes. In the energy sector, synthetic diamonds hold promise for use in high-efficiency electronics and power generation. Diamonds are known for their ability to withstand extreme temperatures and high voltages, making them ideal for use in electronics that require high performance and stability. By creating diamonds from organic materials, researchers could reduce the cost of production while providing a more environmentally friendly alternative to traditional materials. For instance, diamonds could be used in power transistors, improving the efficiency of solar cells and electric vehicles. As the demand for renewable energy sources and more efficient energy systems increases, the role of diamonds in these technologies will likely grow, and sustainable production methods will become increasingly important. Beyond industrial and technological applications, the transformation of peanut butter into diamonds also highlights the growing importance of sustainability in material science. With global concerns over climate change, resource depletion, and environmental degradation, industries are under increasing pressure to find ways to reduce their carbon footprint and create more sustainable products. The ability to produce diamonds from organic, renewable materials offers a glimpse into a future where sustainability is prioritized in manufacturing. By harnessing waste materials and transforming them into high-value products, we can reduce reliance on finite resources, cut down on pollution, and minimize the environmental impact of industrial production. The process of converting peanut butter into diamonds also underscores the importance of scientific innovation in solving global challenges. As researchers continue to refine the methods for creating diamonds from organic materials, we may see even more breakthroughs that make other high-value materials, such as metals, semiconductors, and rare earth elements, more accessible and sustainable. The ability to manipulate materials at the molecular level could unlock new possibilities for everything from clean energy production to environmental remediation. By pushing the boundaries of what's possible, scientists are helping to shape a more sustainable and equitable future for generations to come. Moreover, as new techniques for synthetic diamond production become more widespread, the cultural perception of diamonds may evolve. Once seen as symbols of luxury and wealth, diamonds may become symbols of progress and innovation. As diamonds made from organic waste enter mainstream industries, they could become a reflection of the growing shift toward sustainability and responsible production. This change could lead to a re-evaluation of consumer habits, with more people seeking diamonds that are ethically sourced and produced using sustainable methods, similar to the increasing demand for ethically produced food, clothing, and other goods. As we look ahead, The ongoing exploration of how peanut butter and other organic materials can be turned into diamonds is just the beginning of a larger revolution in material science. What started as a scientific experiment has the potential to reshape industries, drive sustainability, and create new opportunities for innovation across a wide range of fields. Whether it's in manufacturing, healthcare, energy, or environmental conservation. The ability to produce high-value materials like diamonds from common, renewable sources holds the promise of a brighter, more sustainable future. The journey from peanut butter to diamonds is not just a quirky scientific feat, it's a glimpse into the limitless possibilities of material science, sustainability, and the future of human ingenuity.